Greetings and welcome to the introduction to astronomy. In this week's special topic in astronomy, we are going to discuss what is meant by a habitable zone in astronomy. So what do we mean by a habitable zone? Well, let's look first at the definition. So what is the definition of a habitable zone? It is a region around a star where liquid water could be present on a planet's surface. It does not mean that liquid water is there. It simply means that the temperatures are right. So if we look at our three images to the right hand side here, we see that there are three different stars there of different colors and therefore of different temperatures. A very hot blue star at the top has a very wide habitable zone seen in the green, and it's also much farther away from the star. A middle yellow star has a smaller habitable zone and it comes in a little bit closer. You need to be closer to the cooler star in order for the temperatures to be correct. And then we have the much cooler red star, which also has a habitable zone there in the green, but is much smaller and much closer into the star. Now that means that when we're looking for stars and habitable planets, we tend to want to look around middle-sized stars like the Earth. Why? When the hotter stars have an even bigger habitable zone? Well, they also have a very short lifespan. So that blue star doesn't live for a very long time. And we'd think that might not be long enough for life to be able to evolve. Now let's take a look at some of these. So again, what does this mean for us? The habitable zone does not mean that life is present. That is not the case. You also have to have an atmosphere with sufficient pressure. But any rocky planets located in this zone are potentially habitable. They are places where we might want to look for the possibility of life. Now let's look at this in a couple of different solar systems here. And we have on the bottom, we have, of course, our own solar system, and we can see Earth there with Venus on the inner edge, just kind of off the inner edge of the habitable zone, and Mars off to the outer edges of it as well, and Earth kind of plopped there in the middle. Now we also see another system there, and that is known as the TRAPPIST-1 system. That has a number of planets around the star. Now note that it's a much cooler star. They're in a lot closer. So you can see where it zooms into our inner portion much closer than Mercury. But there are several planets there, E, F, and G, which are all in the habitable zone of that star. Now, what does that tell us? Well, it tells us nothing. That doesn't mean that life is present on any of those. It simply means that if those planets happen to have a solid surface, then liquid water might exist on them. So we could say the same thing about our solar system. Venus is slightly out of it, but Earth and Mars could have liquid water. Now Mars, being at the edge of this and being a lot smaller, doesn't have the atmosphere to have liquid water. Although you can also consider that there is another object within our habitable zone, which is our moon. And our moon would not have liquid water on its surface, even though it is a rocky surface within the habitable zone. So we have to come back. You do need that atmosphere is something very important as well. But these are just the planets where we want to look for the possibility of life. Now, when we look at other exoplanets, that there have been other planets detected in habitable zones of their stars. We see several around the TRAPPIST-1 system here, but there are also others, and we can see several of those in the chart here, with Earth up at the very top of our image there. And then as we work down, we can see plenty of other different stars. So there's Earth up there, and we can see several others, Kepler ones, and various other different objects that have been visited. And we can actually see the TRAPPIST-1s down there, down toward the bottom. There's some of the TRAPPIST-1s that are visible here as well. Some of those TRAPPIST-1s planets that are also around their stars and in the habitable zone. Now, how how much you want to consider. You can consider there's an optimistic and a conservative. So if you want to be careful on it, that's the green to the blue line. If you want to be a little more optimistic, you can move down to the red as to whether those would be able to have water. Here we're looking at the temperatures relative to the sun. So the TRAPPIST-1 system is around a very cool star as compared to our sun here at 100% of the temperature of the sun. So the TRAPPIST-1 system less than half of that. But again, we're starting to see these are all planets that exist within the habitable zones of the star. And we also have to consider, what are the other conditions? What else do we need for life to be present? So what are those other conditions that we might need? So let's go ahead and finish up with our summary. And what we've looked at today is the habitable zone. And the habitable zone of a star is the region where liquid water could exist on the surface. It does not mean that life exists. So it's very definitely does not mean that life exists, or even that it could exist. But we are now beginning to detect many Earth-like planets that are located in those habitable zones of their stars. So that concludes this special topic in astronomy on the habitable zone. We'll be back again next week for another special topic in astronomy. So until then, have a great day, everyone, and I will see you in class.